So I'm going to say this at the start of each video. If I'm not going to do proofs anymore for these, you should be doing a proof every time to check your answer. But you already know how to do proofs. We've done this a million times, and I feel like it's going to just burn up a lot of my time. The videos will take longer to get to you, and you already should know how to do it. So I'm going to say this. You should do a proof, but I haven't. I won't have done the proofs for these problems. So there's the off chance that I make a mistake and I actually come up with the wrong numbers. So if you do a proof and you find that I found the wrong solution, which I would have known if I did a proof, contact me. I'll give you 5 bonus points on the quiz. If I'm not promising that there are errors. I'm just saying that I'm not doing a proof, so I don't know, and you could find out. So let's start this problem, but do the proofs. So we're doing elimination, and what elimination means is that we add the two equations together. So I don't want to modify the original equations. I want you to see what they are, but I can actually add them. Sorry about that. I can actually add them without modifying them. Just I put them all together, and what's below is their combined single equation. And in this particular case, note this, that this negative y and this positive y are exact opposites, and they're going to cancel out. So since they're going to cancel out, we have eliminated one of the variables, and that's why it's called elimination. You're eliminating one of the variables. You've seen us do that in substitution by putting in something else for what that's worth, but so that we're left with only one. As I say in class, you can't solve an equation with more than one variable, because if one of them changes value, the other one will change value, so you can never nail it down. But if you can get it to a single variable by either plugging in something that uses the first variable or making them go away in this case, or putting in a number for it because you know what the value is, all of those ways will leave you with a single variable, and then you can solve for that final variable. So combining these, we get 3x equals 30. Oh, that was easy, because look, 3x divided by 3 equals 30 divided by 3, and we get x equals 10. Seems like we're halfway there. We've already got one of the variables. So now what we need to do is we need to substitute that in to find out what the other variable is. So I'm going to take the simpler equation, x minus y equals 11, and I'm going to say parentheses and call that 10 because we think it's 10. And we get 10 minus y equals 11. So I'm going to say minus 10, and we get negative y equals 1. So we're not down to y equals. We need to divide it by negative 1. That's the number that's in front of the variable. And so that's what we need to divide by, negative 1. And we get y equals negative 1. And again, not going to do proofs on these because you're going to do the proofs and you're going to tell me if I made a mistake. In any case, I want to identify what the final solution is. So I say 10, comma, negative 1. Okay, we are using elimination here, but you'll notice if you look at these two equations that we've got a positive 2y and another positive 2y. So if we added them together, they wouldn't eliminate out. So what we need to do is we need to actually take one of the equations, and let's just say, it doesn't really matter, let's say let's take 8x plus 2y equals 30, and let's multiply the whole thing by negative 1. So doing that and multiplying every term by negative 1, we get negative 8x minus 2y equals negative 30. We've changed the sign of everything. Now that I've done that, I'm going to let me just put a little dividing line here so you can see. Now we're at an equation that we can use, and we're going to take the other equation. that was originally given to us, 7x plus 2y equals 24. Now that we've multiplied 1 by negative 1, we can add them together now. So we get negative x, that goes away, equals negative 6. And now we can just divide by negative 1 and find that x equals 6. Great. We still need to know what the other variable is. So we can take either equation. Let's take 7x plus 2y equals 24. And let's substitute in 6 for x. 7 parentheses 6 plus 2y equals 24. And of course, 42 plus 2y equals 24. Subtract 42, subtract 42, and we get 2y equals 24 minus 42. You might remember that I have a little trick that says if you're taking away more than you've got, and we are, we've only got 24, but we're trying to take away more than that, 42, we can switch the numbers, subtract the smaller one from the bigger one, and then we make our answer negative. So we have then negative 18. I'm happy to talk about why that works with anyone. Let's for now just know that it does, but I really would love to talk about it with anyone. I love talking about my math tricks. So if you can come to me and visit me and say, hey, how did that work? Then I'm happy to talk about it. Y equals negative 9. So we will write it as an ordered pair, 6 comma negative 9, and do a proof on that. See if I was right. Do a proof on both of them. If you don't do it on both equations, then it might work for one. It could be some point along one of the lines, but it doesn't work for the other, meaning it's not the point where they cross, and it's not a point for both lines. So do a proof on both equations, and if you found a mistake, let me know as soon as you know, and I will give you 5 points on that. So here we're using elimination, and as you can see, we need to modify at least one of these equations in order to make it match what's on the other one. I'm going to do it twice. I'm going to show you two different things. And first I want to point out what I'm going to do here. Notice this. Right here we have an x, and the exact opposite of the x is here. There's negative 4x, so we could have 4x here, and then they would combine. That means we would have to multiply this by 4. Okay, so I'm going to write that right here. I'm going to say, okay, what if you did 4 times x minus 3y equals 4 times negative 6? And you got 4x minus 12y equals negative 24. Okay? Then you could add I'm going to draw the line here to separate it, and you could say, now we're going to take that other original equation, negative 4x plus 9y equals 9, and add them together. And those go away, the x's go away, we get negative 3y equals negative 24 plus 9. Remember my trick? You do 24 minus 9, switching them, and then you get 15. So we'll have an answer will be negative 15. And then, of course, divide both sides by negative 3, and you get y equals 5. That would be if we modified this equation here by multiplying it by 4, so we matched the negative 4 on these x's, right? Okay, now, we could do something else, though. We could, if we wanted to, try and eliminate the y's. And notice this. If I took this equation and I multiplied it by 3, I would have negative 9y's now, which is the exact opposite of those positive 9y's. So now I'm going to do that same thing. And I'm going to say over here, 3 parentheses x minus 3y equals 3 parentheses negative 6. Distribute that 3 through, and I get 3x minus 9y equals negative 18. And now that I've got this new equation, I'm going to draw a line to kind of mark it off and show you that I'm now using that equation and the other equation that we had, negative 4x plus 9y equals 9. That's this equation here, just getting put down in front of it, and now we were going to combine them. 3x minus 4x equals negative x. The negative 9y and the positive 9y go away, and when we combine negative 18 and 9, we get negative 9. So, since this is negative x, we don't want to say negative x, we want to say x. We divide by whatever the coefficient is, negative 1 in this case. X equals 9. And so we get 9 comma 5. And I'm not going to do proofs, so you know how to do them. You're going to do a proof on this one, and you're going to tell me